Good morning friends. Today I am going to explain what is self-induction, and this is one of the important topic in electromagnetic induction. So what is this electromagnetic induction? In this chapter mainly we are going to talk about the how the magnetic field is produced due to the current and how the current is set up in the coil due to the change in magnetic field. Okay. So what is self-induction? When a current is flows through a coil, it produces a magnetic flux, okay, which is linked with the same coil. If the current is changed, the flux linked with the same coil is also changes, so due to which an induced EMF is set up in the coil. What is EMF? EMF is nothing but it's a electromotive forces which derives the electrons and which is produced in the coil, and this is against the current according to the Lenz law. What is this? According to the Lenz law, this produced EMF and the current are in opposite direction, and this phenomenon is called the self-induction. The induced EMF is called the back EMF or the self-induced EMF. Now, what is coefficient of self-induction? Here, the total magnetic flux phi b link with a coil is proportional to the current I. Here, what is coefficient of self-induction? That is the total magnetic flux phi b is linked with the same coil is proportional to the current I. So that can be written as here phi b is proportional to the current I, and this implies when you take out the proportionality we have to introduce the some constant that is equal to the Li. Let us take this is equation number 1 where L is called the coefficient of self-induction. Induction. Now, when the unit current is flows through this circuit, or we can write I is equal to 1. So this implies phi b is equal to the L. Okay. Here, by this we can write the definition of self-inductance is self-induction is numerically equal to the magnetic flux when unit current flows through it. So this is the first definition for the self-induction. Now we are going to derive for the second definition according to the Faraday's second law. What is the Faraday's second law? That is E is equal to minus d phi b by dt. So that is change in electricity produces the change in magnetism produces the electricity. Here this is by this we have to write we have to derive the second derivation for the self induction. Here induced EMF is equal to the minus d phi by dt. We know that phi b is equal to the Li. Just now we derived this one. Phi b is equal to the Li. Now if you substitute this Li value in this equation, then E is equal to minus d by dt, or Li we can write here E is equal to minus d of this d I, L is taken out. Here E is equal to minus L di by dt. Then we can write E is equal to minus L when di by dt is equal to the 1. So the negative sign indicates here that induced EMF in such a direction that which opposes the change. Okay, here when di by dt is equal to the 1, so that time the induced EMF is equal to the negative of the coefficient of the self induction. Or we can say that the coefficient of self induction is numerically equal to the induced EMF in the coil when the rate of change of current is unity. So we can write the coefficient of self inductance is numerically equal to induced EMF when the rate of change of current is unity. Thank you. For more videos, subscribe my channel Physics.